Let's learn how to solve limiting reactant problems. When a stoichiometry problem gives you a chemical equation and either the mass or moles or gas volumes of two reactants, before you can solve the problem you must determine which reactant is limiting, because that is the reactant you must use to solve the problem. If you use the other reactant to solve the problem, you'll get an answer that is too big. Let's take a sample problem. There is a way to prepare nitrogen gas by reacting ammonia gas with hot copper-2 oxide to form the nitrogen gas, copper metal, and steam. The problem we have is if 18.1 grams of ammonia is reacted with 90.4 grams of copper-2 oxide, how many grams of nitrogen gas will be formed? Well, first you need a balanced chemical equation, and so we double the ammonia to take care of the nitrogen gas. We triple the copper-2 oxide to give us enough oxygen. We then have to triple the metal copper moles, and we have to triple the amount of water to handle all of the hydrogen. Then we find the moles of each reactant. That's our next step. Well, we take the 18.1 grams of ammonia, divide by its molar mass 17, and we get 1.06 moles of ammonia. We divide the 90.4 grams of the copper-2 oxide by the 79.5 grams per mole molar mass of it. We get 1.14 moles of copper-2 oxide. Now the problem becomes, if 1.06 moles of ammonia is reacted to 1.14 moles of copper-2 oxide, how many grams of nitrogen gas will be formed? That's easier. We first put down the balanced chemical equation. We saw it before. And now we ask, 1.06 moles of ammonia, how much of the copper-2 oxide will it need? Well, the ratio of moles is 3 to 2, or 1.5. 1.5 moles of copper-2 oxide are required for every mole of ammonia. Well, we have 1.06 moles of ammonia. We multiply that by the 1.50 ratio, we get 1.59 moles of copper-2 oxide needed for all that ammonia. Trouble is, we have only 1.14 moles of the copper-2 oxide. Not enough. We have too much ammonia for the available copper-2 oxide. Therefore, ammonia is in excess and copper-2 oxide is the limiting reactant. That's the one we're going to use. Now the problem becomes, if excess ammonia is reacted with 1.14 moles of copper-2 oxide, how many grams of nitrogen gas will be formed? This is a problem like those you've seen before. So we solve for the mass of nitrogen. Well, we go with 1.14 moles of our limiting reactant, copper-2 oxide. We look at the balanced chemical equation and we see that we would have 1 mole of nitrogen produced from 3 moles of copper-2 oxide. So we write that ratio down here. That'll get rid of our moles of copper-2 oxide. And then to find the mass of the nitrogen, we multiply by the molar mass of nitrogen gas, 28 grams per mole. When we do all that, we get 10.6 grams of nitrogen gas. And that's a reasonable answer given the amount of ammonia we had. So the method of solving limiting reactant problems is as follows. First, you determine what you know and what you need to solve for. Then you're going to write a balanced chemical equation, as we always do. Then you'll determine how many moles of each reactant you have from the grams or a mole, or, well, you may have moles to begin with, or the volume. And starting with either reactant and its number of moles, you're going to find out how many moles of the other reactant you'd need to completely combine with it. Determine which of the two you have too much of, and the other one is the limiting reactant that you will use in solving the problem. Now let's do an example. You can do this yourself and then turn off the video once you've seen the problem and solve it, and then come back and check the solution. Barium peroxide reacts with acids. Barium peroxide was the first peroxide, metal peroxide, to be discovered. and so it reacts with acid to form hydrogen peroxide. So the question is, what mass of hydrogen peroxide should be formed from reacting 1.50 grams of barium peroxide with 0.68 grams of hydrochloric acid? Solve the problem after you turn off the video, and then check the answer on the next slides. Now, what do we have? Find what we have and what we want. We have the amount of barium peroxide and hydrochloric acid. We're looking for grams of hydrogen peroxide, so that should be the last thing that we solve for. Second thing we do is find the moles of each reactant given this problem. Well, for barium peroxide, we have 1,500 milligrams. It's a whole lot easier to work with milligrams, so you just multiply both of these by 1,000. So we divide 1,500 milligrams by the 169.33 milligrams per millimole, that is the barium peroxide molar mass. That gives us 8.86 millimoles of barium peroxide. Then we solve for the HCl. We have 680 milligrams divided by the 36.5 molar mass, gives us 18.6 millimoles. Now, how much hydrochloric acid do we need for this amount of barium peroxide? Well, we take the 8.86 millimoles of barium peroxide and we multiply it by the ratio from the balanced equation. 2 millimoles of hydrochloric acid would be needed for 1 millimole of barium peroxide. When we do that, we find that we need 17.7 millimoles of hydrochloric acid. However, we have 18.6 millimoles of hydrochloric acid, more than we need. HCl is in excess by 1.1 millimole. Now we then know that the limiting reactant must be the other reactant. Barium peroxide is the limiting reactant. We now rewrite the question in this way. What mass of hydrogen peroxide should be formed from reacting 8.86 millimoles of barium peroxide with excess hydrochloric acid? A very easy problem to solve. We can plug the numbers in now. Grams of hydrogen peroxide would be 8.86 millimoles of barium peroxide. Get rid of that. Times 1 millimole, see from the equation, 1 millimole of hydrogen peroxide is formed from 1 millimole of barium peroxide, so we have a 1-to-1 ratio there. And then we multiply by the mass, molar mass of the hydrogen peroxide, 34 milligrams per millimole. This then gives us 301 milligrams of H2O2, or 0.301 grams, a reasonable answer, given the fact that the barium does not appear in the needed product, H2O2. These are the steps you will follow to solve any limiting reactant problem.